Okay, let's start with question number 1. A displacement d of 100 meters from the origin at an angle of 37 degrees above the x-axis is the result of 3 successive displacements: d1 of 100 meters along the negative x-axis, d2 of 200 meters at an angle of 150 degrees above the x-axis, and a displacement d3. Okay, so that's supposed to be corrected. It's supposed to be a displacement d3. What happened? My internet disappeared somehow. Just a minute. Okay, can we see the presentation?
Yes, sir.
All right, so let's go back to business. Yeah, okay. So a displacement d is a displacement of d from a displacement d of 100 meters from the origin at an angle of 37 degrees above the x-axis is the result of 3 successive displacements: d1 100 meters along the negative x-axis, d2 200 meters at an angle of 150 degrees above the x-axis, and a displacement d3. Find d3. So basically what we mean here when we say d is the result of 3 successive displacements, basically it means for you to get d, you need to add d1 plus d2 plus d3, some kind of a mathematical stuff. So that's what I'm going to show. It's an addition thing. To get just a minute, that person needs to wait a bit. So we have to add vectors. We have to add d1, d2 and d3. If you add d1, d2 and d3, then we end up getting capital D, the vector d. Okay. To get vector d, so I need to type something. We add vectors a minute. Yeah. So basically, what the heck have I written? Yeah. So basically, that's what. So the question, I've put it in bold. Then the explanation I'm trying to offer, I've put it. I'm typing under there. So basically, for us to get D, we need to add the other vectors, D1 plus D2 plus D3. It doesn't matter where the vector is pointing, as long as you did addition, you're doing addition, you can just add the vectors like that. D is equals to D1, D2 plus D3. So we know what D is, capital D, we know capital D, we know D1, we know D2. The only thing we do not know is D3. That's what you're looking for, because we've been asked to find D3. That's what you're looking for, and that's what you don't know. Okay, kind of doesn't look nice. Some stuff has been lost in the thing. Okay. Now the next thing to do is, if you have been given vectors, what you want to do is you want to put your vectors on a table. For each vector, you want to work out how much is the x component and how much is the y component for each particular vector. Okay. For each vector, you want to work out how much is the x component, you want to work out how much is the y component. And that's what we're going to do using this table, which I have here, table 1. So the next question is, using that table, how do you work out, how do you find the x component of a vector? And how do you find the y component of a vector? That's the next question I'm asking. How do you find the x component of a vector? And how do you find the y component of a vector? Does someone know how to do that? How does a person find the x component of a vector and the y component of a vector?
For the x component, we get the vector cos the angle at which the vector is at, and then for the y component we get the vector sine the angle which is at.
We get the vector, or what? Is it the size of the vector or the vector?
The vector itself. We are going to use the x and y component to find the magnitude later, but for now we use the vector which we've been given.
So if you're given vector A, then you want to find the x component of vector A, how do we do that?
Then we are going to get A cos the angle at which A is at.
Okay, so basically, alright, so I think that's very clear. So what you do, if you want to find the x component of a vector, you get the size of the vector, which is the magnitude of the vector, times the angle the vector makes with the positive x-axis. Okay? The size of the vector times the angle that particular vector makes with the positive x-axis, measured anticlockwise. The angle should be measured anticlockwise. For the y component, you get the size of the vector times the angle, times the sine of the angle the vector makes with the positive x-axis measured anticlockwise. So in our case, for this one, D1, how do we get the x component of D1? D1x. D1x would be how much? D1x. How much would be D1x? How do we get D1x?
It's negative 100.
Huh?
Negative 100.
How did you get negative 100?
100 cos 180 degrees.
Sorry?
Along the negative axis.
100 cos 180. So the size, so first you start with the size. You have to write it properly. The size of the vector is d1. Then the angle is cos 180. The angle it makes with the x-axis is cos 180. Like that. d1 cos 180, because d1, from what we are taught, d1 has a size of 100 meters. That's the size of d1, and it is along the negative x-axis. For you to reach the negative x-axis, we measure the angle from the positive x-axis. So the angle between the positive x-axis and the negative x-axis is 180. Okay, you always measure your angles from the positive x-axis, then you go in a anti-clockwise direction. So how much is d1? The size? What's the size of d1?
Negative 100.
The size of d1. D1, what's the size? I'm not asking about how much is d1.
Negative 100.
Why is it negative 100? Where is the negative coming from? I'm asking for the size of d1. The size, what's the magnitude of d1?
100.
Yes, the size is 100. The size of the vector,
100 meters.
yes, the size of the vector is 100 meters. So I don't know where people are trying to get this negative 100. Okay, let's not get ahead of ourselves. Do things step by step. So here, so d1x is going to be d1, the size of the vector, the size of the vector multiplied by the angle, which is 180. So we replace the size d1. We've been given d1 has a size of 100 meters, so it's going to be 100 meters times cosine of the angle. The angle is 180 degrees. So this is going to give us how much? 100 meters times cosine cos 180. That will give you how much?
Negative 100 meters.
That will give you negative 100 meters.
Yes.
Someone's microphone is on. Shymost, only switch on your microphone if you're about to speak. So that's how we get d1x. d1x is equals to d1 cos the angle d1 makes. Okay, actually I would have written it like this. Cos d1 cos theta 1. Whatever the angle that d1 makes. And in this case the angle is happens to, so d1 cos theta 1, and the angle which d1 makes is 180. The size of d1 is 100 meters, the angle it makes is 180, and when you multiply those things, we get our d1x as minus 100 meters. Similarly, we have to work out the y component of d1. So we need to work out d1y. How are we going to get d1y? d1y, how are we going to get d1y?
100 sine 180.
How much?
100 sine 180.
The 100 is what? What is the 100?
We'll get the magnitude of vector d1.
Yes. The magnitude of
multiplied
it.
by
Yes.
multiplied by the sine of the angle that it makes with the positive x-axis.
Exactly. We get the magnitude of vector d1 multiplied by the sine of the angle it makes with the positive x-axis, like that. d1 there. d1, which is the magnitude of vector d1, then the sine of the angle it makes. So next thing is the magnitude of vector d1. How much is the magnitude? What is the size of vector d1?
100 meters.
100 meters. Yes, 100 meters. And the angle is how much?
180.
180. Like that. So you have d1 is equals to 100 meters times sin 180. How much is that? 100 meters times sin 180.
0.
0 meters. It's not just 0, it's 0 meters. Meters. So you see something here. When a vector lies along the negative x-axis, it has a size of minus 100 meters, and it does not have any y component. The y component is 0. That's one thing to learn. When a vector lies along a particular axis, in this case the negative x-axis, it has got no y component. The y component comes out to be 0. Okay, now let's move on to d2. We need to find d2x How do we get d2x? Just a minute, there's a mistake somewhere. How do we get d2x?
The magnitude of d2,
which is d2,
was the angle it makes.
Okay, so magnitude of d2, then cos the angle it makes with the positive x-axis, like that. How much is, what's the magnitude of d2?
200 meters.
200 meters. Then cos, how much is the angle?
150.
150 degrees. Just a minute. There, 200 meters cos 150 degrees. And how much is that?
Negative.
I think
Negative how much?
negative 173.21.
173.21
or 205. Because I rounded it off.
Okay, we'll just write negative 173.2. If just a bit, we'll confirm if this is, it's okay. Is that okay?
Yes.
Okay. Next, we move on to d2y. d2y. How do you find d2y?
The magnitude of d2.
Okay, that is d2.
Sine the angle it makes with the positive x-axis.
Sine the angle it makes with the positive x-axis. There, d2y is equal to d2 sine the angle it makes the positive x-axis. So how much is d2?
200 meters.
200 meters. Then sine, how much is the angle?
150.
150. And how much do we get for this? 200 meters times sine 150?
100.
100 meters.
100 meters. Okay. Okay, then the second bit is this guy, D3. Do we know anything about D3?
No.
No, that's the correct answer. We don't know a lot about D3. So how much is D3x? D3x, we do not know how much it is. Whatever it is, we'll have to find out. Okay? It is okay if you do not know something at a particular time. Is that clear? It is okay if you do not know something at a particular time. Okay, so D3x, we do not know yet. We are going to find out. That's what we want to find out. How about D3y? Do we know something about D3y?
No.
No. Again, that's a correct answer. We do not know stuff about D3y. It's okay not to know. So if you do not know what the x component of D3y is, you just write D3x, D3y, like that. You put some question marks there because that's what you'll be looking for. Okay. The other vector we are looking for, we know, is vector D, capital D. We need to find dx. How much is dx? We need to find how much is dy. Vector capital D, the resultant vector. Vector D is the resultant vector. There, vector D. We are told vector D is how much? There, 100 meters at an angle of 37 degrees. That's what you're told. Vector D has got a size of 100 meters at an angle of 37 degrees. That's I think I probably need to add it on the table of component on the caption here. And just a minute. Theta equals to 37. Just a minute. These are the slots at 31. I think it was 180 degrees. I'm trying to add some more information. And 32. D3. Okay, so I've added some information about angles in the table there. So we have vector D1 at 100 meters, and theta 1 is 180 degrees. D2 has got 200 meters size at an angle of 150 degrees. D3, it's at an angle we do not know, theta 3, but we have got D 100 meters at an angle of 37 degrees. So how do we find dx? How do you find dx? Using this information?
We can use the fact that the vector D is a resultant of...
How do we find dx?
We get the magnitude of D.
Yes.
Multiplied by the cos of the angle it makes with the
okay,
x-axis.
which is that, like that, D cos theta. Then how much is D?
100 meters.
100 meters. Then cos, how much is the angle?
37 degrees.
37 degrees. Like that. So how much is that? 100 meters times cos 37 degrees?
79.86
79.86
meters.
So basically 79.7. Like that. How do you find dy?
So I think it's maybe 79.9.
What do you have? 79 point what?
79.86, or which one around?
79.86. What's 79.9? Huh? Yeah, 9. Okay. Then how do you find dy?
We get the magnitude of D
Which is-
multiplied by the angle it makes with the positive x-axis.
Okay, like that. D sin theta. Then how much is D?
100 meters.
100 meters. Then how much is the angle?
37 degrees.
37 degrees. So how much is that? 100 meters times sine 37 degrees.
60.188.
Wait, 60 point
18.
wait, that's 60.2 then. Okay, so our table appears complete. We have vector d1. We know the x component of d1, d1x is minus 100 meters. D1y, it's 0 meters. We have vector d2. The x component of d2 is d2x, is minus 173.2 meters. Then you've got d2y, which is 100 meters. Then d3 we do not know. D3x we do not know. D3y we do not know. But we know dx is 79.9. dy is 60.2 meters. So the next thing to do is you have to remember how you get this vector. Remember this. For you to get vector d, you need to add vector d1 plus vector d2 plus vector d3. Okay. However, when you are adding vectors, the way you go about adding vectors is you add the x components of those vectors together, and then you add the y components of the vectors together. So basically, the equation we have, this equation, d is equals to d1 plus d2 plus d3. We can rewrite that equation in terms of components. Okay, we can rewrite the equation as follows. We can rewrite the above equation in terms of x and y components as follows. Begin equation. So it's going to be dx is going to be equals to d1 1x plus d2 d2x plus d3 3x. That's one equation. That we can do this. This is how you add vectors. When you're adding vectors, you add the x components together. Dx is going to be d1x plus d2x plus d3x. Then next, you have dy is going to be equals to d1y plus d2y plus d3y. That's what you're going to have. So you have got dx is going to be equals to d1x plus d2x plus d3x, like that. Dy is going to be d1x plus d2y by this. Most of these things you already have from the table. We have got dx, you have got dy, you have got d1x, you have got dy1, you have got d2x, you have got d2y. The only things we don't have are d3x and d3y, and those are things we are looking for. So we just substitute. We substitute with values from this table. Okay, so we start with the x. So in that particular case, with x, we are going to end up with the dx is 97 meters, then the d1x is 100 meters, then the d2x is minus 173.2 meters, then the dx is negative. Oh, sorry? Yes, tutorial with first years. Okay, so that's what we're going to do. So we'll substitute. So in our case, so dx, whatever we have from the table, that's the value we're going to put there. So from the table, we have a value of 79.9. From the table, where is it? There it is. $79.9. Then d1x from the table, d1x is minus 100. Mr. Nyama, yes, Dr. Nyirenda was looking for you.
Dr. Nyirenda?
Yes, chemistry.
Oh.
He just came like 2 minutes ago.
Okay.
Yeah.
Okay, let me see.
All right. Minus 100. Then d2x From the table, d2x is another minus 172 plus, then there's another one minus, what is that, d2x, this one. There. For dx, so we got dx is equals to d1x plus d2x plus d3x. So dx is 79.9 meters. Then d1x is 100 meters minus 100 meters plus d2x is minus 173.2 meters plus that. So this one minus 100 meters plus there we get a negative. Do you agree?
Yes, sir.
We get a negative there. So we end up having minus minus. Like that. And that gives us how much? Minus 100 minus 173.2. How much is that?
To give you negative 275, negative 273.21.
Okay, so negative 273.21. Negative 273.21. Like that. So you've got 79.9 this side equals to minus 273.2 meters plus d3x. So we take this negative guy to the other side. When you take it to the other side, we end up having the following. End up having just a minute, something remove bit. So we end up having, so when you check this minus 273.2 meters to the other side, we end up having d3x is equals to 273.2 meters plus 79.9 meters. So how much is that? How much is 273.2 times plus 79.9?
353.1.
353.1. Okay.
353.1 meters.
All right. Like that? Where is it? Like this? Is that correct? Okay. We do a similar thing for dy. We follow the same process for dy. The same process I followed here, we follow it for dy. So we substitute the value for dy. What value we have for dy? Substitute. It's 60. 60.2.
Yes.
All right. dy is 60.2. Just a minute. That's 2. Then d1x d1x I will check that on the table. d1x is d1y That's 0 meters. Someone is looking for admission. Then D2Y D2Y from the table is, as you can see here, 100 meters. So we have 60. dy is 60.2 meters. Then d1y is 100 meters. Sorry, 0 meters. Then d2y is 100 meters. Then d3y is d3y. There. So 0 plus 100 meters is how much?
100.
100. Like that. So then we take this 100 to the other side so that we can work out d3y. So it's going to become minus. So we end up having, just a minute. So we end up having d3y equals to 60.2 meters minus 100 meters. How much is that?
We are going to have negative 39.8.
Negative 39.8. Like that. So we know d3x is 353.1 meters. Then d3y is negative 39.8 meters. That's what we know. Next, we can find the magnitude of d3. The magnitude of d3. How do you get the magnitude of a vector? Next, we can, just a minute, let me see something. Okay. All right. How do you get the magnitude of a vector? We calculate the magnitude of vector. How do you work out the magnitude of a vector? Hello?
Sorry, sir, repeat the question. I couldn't get it.
How do you get the magnitude of a vector? Now that we have the components, how do we get the size of the vector? Vector D3.
D3 will be equal to the square root of D3x squared
Yes.
plus D3y squared.
Yeah, exactly. Minute. Size. Square root of D3x squared plus there. That's how we get the size. The size of a vector, in this case, D3, which we want, is going to be equal to the square root of D3x. Maybe I can write it much better. D3x like that. So D3x squared plus D3y squared. And we know we have D3x and D3y. So we just substitute. Where is D3x? This is D3x. A minute. Now, how much is the stuff in the square root? In the square root, how much is the thing in the square root? How much? $353.1 squared plus brackets 39.8 squared. How much is that?
$355.3.
I only want the stuff in the square root because we still have to work out the square root.
So we have the square root of 126.
One what?
1,240.
1,000?
126,242.
126. Then 200 and what?
242.97.
42.97. Like that. Then what do we get when you square that? When you do a square root of that?
355.3.
355.3. Okay. So basically our answer, the size is, we can do a following, basically 355. That's the size. There. So it's approximately equals to 355 meters. The next bits, you have to look at where the vector lies. On the xy plane, this vector, vector d3, so I will write on the xy plane, vector d3 lies along the positive x-axis, Vector d3 has a component, has an x component, which lies along the positive x-axis, and a y component which lies along the negative y-axis. This on the xy plane, vector d3 has an x component which lies along the positive x-axis. The reason why we are saying that is because this guy, where is that? The reason is the following. That's, you can see this guy d3x is positive. It's 353.1 meters. That's the reason why we're saying that. And y lies along the negative x-axis. The y component lies along the negative x-axis. See the reason? d3y is how much? Is this? Just a minute. Okay. Do we agree? Therefore, vector d3 lies in the fourth quadrant. In the fourth quadrant quadrant of the xy plane. Is this clear to everyone? Vector D3 lies along the positive x-axis. Vector D3, the x component of vector D3 lies along the positive x-axis. The y component of vector D3 lies along the negative y component along the negative x-axis. Therefore, D3 should lie. D3 should be in the fourth quadrant. Is that clear? You can make a simple sketch. I can't make a sketch using this computer, but you can try to make a simple sketch. If this is true, then we can work. The vector. Sorry.
I wanted to ask, like
Yes.
the first statement you've written,
Uh-huh.
say the x component of vector D3 lies along the positive x-axis. Doesn't that mean the angle between the x-axis and the vector is 0, according to the statement you've written?
No, this is an x component. The x component can either lie along the positive x-axis or can lie along the negative x-axis. The y component of a vector can either lie along the positive y-axis or along the negative y-axis. Okay? Components. Components.
Sometimes
Yeah.
the angle is 0.
Sorry?
I'm saying sometimes if the angle is 0, they say
No, we are looking for an angle for vector D3. We are not looking for the angle for the components. We are looking for the angle vector D3 mixed with the positive x-axis. The angles for the components, we already know them. Okay, because a component either lies along the positive y-axis or along the negative y-axis. Okay, the y component. The x component either lies along the negative x-axis or the positive x-axis. In this case, the y component lies along the positive x-axis. Sorry, the x component of vector D3 lies along the positive x-axis. The y component of vector D3 lies along the negative y-axis. That's why we are saying vector D3 is in the fourth quadrant. Okay? So there are two angles. There are two ways you can measure the angle. You can measure the angle from you measure the angle from the x-axis. Okay? So you can measure the angle from the x-axis. From the positive, since this vector is in the fourth quadrant, the nearest x-axis is the positive x-axis. Okay, so from the positive x-axis, you can measure the angle clockwise. But that's not really normally how we measure angles, because we measure angles from the positive x-axis, we go anti-clockwise. Like that. That's what theta is. However, you can also work out an angle which is measured from the positive x-axis but goes in a clockwise direction, and that angle is theta. That angle is phi. Okay. So in this case, next we can measure the direction of vector D3 of vector D3. You can measure the direction of vector D3 from the positive x-axis in two ways, since it lies in the fourth quadrant. The first First way is to measure the angle between the positive x-axis and the vector in an anti-clockwise direction. This angle is denoted theta and is pronounced theta. So there are two ways we can measure the angle between a vector and the x-axis. We measure angles from the positive x-axis. So in this case, because we're using the positive x-axis because this vector is closer to the positive x-axis. That's the axis it's closer to. So the first way is we're going to measure from the positive x-axis, then we're going to go anti-clockwise until we reach the angle. This angle is what is known as theta 3, as theta. Okay? That's what the angle called theta. Actually, let's call it theta 3 or whatever it is. We're just going to go theta, yeah. The second way is to measure the angle from the positive x-axis and the vector in a clockwise direction. This angle is denoted phi and is pronounced phi. So the angles theta. So this is for vector 3, theta 3, the angle theta 3 and phi are related as follows. Theta 3 plus phi is equals to 360 degrees. Theta 3, which is the angle from the positive x-axis, you go in an anti-clockwise direction up to where the vector is, that is your theta 3. Then phi is the angle from the positive x-axis, you go clockwise up to where the vector is. Those two angles are related like that. Then we have the formula, the formula you use for finding the angle between a vector, and that's what we're going to use in this case here. So in this case, we're going to work out, we get the angle phi from the components of vector G3 as follows. Tan phi. Always when you're working out an angle, it's going to be equals to the the y components, the vector. There. Tan phi is equals to d3y divided by d3x. Is this clear?
Yes, sir.
Okay. So we have this information about d3y and d3x. How much is d3y? And how much is d3x? D3y is minus 39 point something something, 0.8. That's what I heard. Then d3x is how much? Okay. Like that. And that gives us how much? Tan phi will be how much? Equals to how much? Minus 39.8 divided by 353.1. How much is that? Negative 0. 113. 3 like that. Is this correct?
Yes.
Okay, so we have what that is. So we can work out what the angle is by working out the inverse, tan inverse of that. So just a minute, let me type a bit something. Again, equation phi is equals to tan inverse tan inverse of that. So here phi is equals to tan inverse of this. How much is this? How much?
-6.447.
6.447. Just a minute. Like that? Is this correct?
Yes, it is.
Okay, so you kind of like we'll write it as just 6.4, I think. Like that. No, this one, the equation we have at the top here, this one, we are supposed to rewrite this as follows. It's supposed to be 360 degrees plus phi, plus phi. Yeah, supposed to be like that. This equation here, theta is going to be this, like this. Since our angle is negative, so we add it to 360 degrees, then it will reduce like that. So we end up having this that down there. So it will be 360 degrees plus this guy. That will give us 360 degrees minus the negative angle, which gives us how much? Just a minute. We get. Can you repeat what you said? 3 what? 53 point what? 6? Like that?
Yes.
Okay. So, this is how you go about working this thing out. The reason why you have to work out a different angle is because your vector is in the fourth quadrant. The fourth quadrant is near to the positive x-axis. So you work out an angle phi. This angle phi, because in the fourth quadrant, is going to come out negative, and that's what we found out here. This negative angle plus 360 degrees, basically it's saying you do 360 degrees, which is the positive x-axis, then you go back in reverse by 4 degrees, by 6.4 degrees. When you do 360 degrees, then you go back in reverse, you end up being at 353.6 degrees. So that is the angle this guy makes, and basically that's how you proceed to work out this thing, like that. The other thing also is, as we discuss these things, the working out, I'll be posting this stuff on your Moodle, okay? So you can see the workouts. We'll be posting this stuff on your Moodle so that you can see the workout of how we actually work out something like that. Okay. And as you can see, when you're doing things online, yes, eventually you get something done, like right now, but it takes a bit of time to do that. Working out stuff online takes time. And this is a reason why I'm suggesting that if we are actually going to make progress, we need more hours. So my suggestion is, we have got Monday 18 hours, we have got Wednesday 18 hours, we have got Tuesday. We need to pick up. I don't know what the other lectures are doing, but in our case, we need to pick up the 18 hours on Thursday. We need to pick up the 18 hours on Friday, so that in total we have 6 hours. In each of those 6, in each hour, if we can work out one question an hour, or we can work out 2 questions. Remember, I said when it comes to online thing and working out problems, usually if you are very fast, you work out 2 questions. At most, if you are slow, like in this case, we have basically in 1 hour, because 1 hour 30, we have actually worked out only one question, but you still follow, you still get engaged. Okay, so basically that's the reason why I say we need more hours. If you're going to actually move forward between Monday and Friday, we need to meet every day. Monday 1 hour, Tuesday we meet for 2 hours, because I've got 2 hours on Tuesday in the morning. Wednesday I can spare an hour, 18 hours. Thursday I can do an hour, 18 hours. Friday I can do an hour, 18. This Friday is going to be a problem because I'm giving out a test to some students. So I will most likely next Friday will be able to meet, but we can meet this Thursday at 18 hours. So I'm going to modify the invitations, the ones for 18 hours. I'm going to include this week, I'm going to include Thursday. Next week I'm going to include Friday, so that we can meet every day. The rest of the days we can meet 1 hour in the evening. On a Tuesday we can meet for 2 hours. That will give us access to 6 hours, so that we can discuss. Mind you, it's not me who is going to answer the exam. You are the people who are going to answer the exam, and you have to be aware of the steps, how to actually go about working out the problem. Okay, so let's move on to question number 2, because we're going up to 11:30. Question number 2, find the direction and magnitude of A plus B, A minus B, B minus A. What you're looking at is this one here. This is what you're looking at here. Vector A is that one, vector B is that one. Again, in this case, we always measure angles from the positive x-axis. Measure the angles from the positive x-axis and go in a anti-clockwise direction. Measure the angles from the positive x-axis and go in an anti-clockwise direction. If you do that, most likely you will not have any problems and things should come out on their own. Okay, so in this case here, for vector A makes an angle of 25 degrees with the negative, this side here, the negative x-axis. Then vector B makes an angle of 20 degrees with the positive x-axis, but in an anti-clockwise direction. That's not how we measure angles. Okay, if you want to do calculations properly, you measure your angles from here, then you go like that, up to there. So in the case of A, the angle is going to be 180 degrees minus 25 degrees. In the case of vector B, the angle is going to be 360 degrees minus 20 degrees. That is going to be a theta, and that's what you use. Is that clear?
Yes.
Always measure your angles from the positive x-axis in an anti-clockwise direction. So it doesn't matter whether you've been given the angles like this. Measure from positive x, go around like that. So in this case, for vector B, it's going to be 360 degrees minus 20 degrees, because they're going in reverse. So 360 minus 20 degrees, it will give you, I think, 340. Then this other side, 180, you go back in reverse, minus 25 degrees, it's going to give you another angle. So basically, that's what we do. So we need, again, in this case, we need a table. That's what we're going to go about, do that. We're going to do a table, because we need a table of components in this case. We will copy and modify the table we have from the first problem. Just that requires a minute on my part, so give me a few minutes to do that. Now, components of vector A, vectors A. So vectors A, is how much? Vector A is how much? Yeah, vector A is 30 meters. 30 meters at an angle of theta. Theta 1 in this case, vector A is 180 degrees minus 25, I think. 25 degrees. Okay, we'll work that out later. Then vector and vector B and vector B. Vector B is 20 meters. Just a minute. Meters on an angle of 360 degrees minus 20 degrees. Okay, then we need vector A. Vector A. Then this side we have AX. AX. Just a minute. We'll be ready to go very soon. And AY. Then Y. Then inside here we have A plus B. Just a minute, we are trying to create a table we're going to use. There's A minus B. A. Okay, let's see what it looks like. Okay, so basically, yeah, this is our table. We have components of vectors. Vector A is, the size of vector A is 300 meters. The angle it makes, theta 1, is 180 degrees minus 25 degrees. 180 minus 25 degrees is how much?
155.
How much?
155.
155 degrees. Okay. So we have the 155 degrees there. So that is the angle A, vector A makes from the positive x-axis. Then vector B, 360 minus 20 degrees. How much is that?
340.
340.
340 degrees. Okay, so we know vector A, the size of vector A, the angle it makes. We know the size of vector B, the angle it makes. So we need to find the components of vector A and vector B. How do we get AX? How do you get AX?
To be 30.
How? How do you get a
45.
component of a vector?
To be 30 multiplied by cos 155.
Okay, so the size of vector A, then cos the angle, theta 1. That is, the size is how much? How much is A?
30 meters.
30 meters. Then cos the angle is how much?
155.
155. That gives us how much? 30 meters cos 155. How much is that?
Negative 27.189.
0.189. So basically that is negative 27.2. Next, how do we get AY? How do we get AY?
The magnitude of vector A
Mhm.
multiplied by the sine of the angle A makes with the positive x-axis.
Okay, that is like that. Okay, so how much is A?
12.6.
How much is A? How much is A?
30 meters.
Uh-huh. Then the angle is how much?
155.
The angle.
155.
Yes. So that is 30 meters sine 155, 30 meters times sine 155. That gives you how much?
$12.7.
12.7 meters. Just a bit. There. Next, we move on to B. How do you get BX? How do we get BX?
The magnitude of vector B multiplied by the cos of the angle it makes with the positive x-axis.
Okay, like that. How much is B?
20
20.
meters. And how much is the angle it makes?
340.
340. There. So 20 meters times cos 340 degrees. How much do you get? How much do you get for that?
18.8.
18.8. There. Next, BY. How do you get BY? Oh, there's a mistake somewhere. Just a minute. Yeah, how do you get BY?
The magnitude of vector B multiplied by the sine of the angle it makes with the positive x-axis.
Okay, so like that. So what's the magnitude of vector B?
20 meters.
Then the angle is how much?
340 degrees.
Okay, so how much is 20 times sine 340 degrees?
Negative 6.8.
Negative 6.8 meters. Now thoughts. Okay, next, if we are going to do a plus b, a minus b, b minus x, we need to add the components. We need to subtract the components. So in this case, we need to find the components of a plus b. A plus b components, a plus b x. We need to find a plus b x. Just a minute. We need to find a plus b x. Yeah, we need to find a plus b x. We need to find a plus b y. Just a minute. Just a minute. A minus a. X. Yeah, we need to find these guys. A plus bx, the x component of a plus b. So this a plus b is going to have an x component, it's going to have a y component. This a minus b is going to have an x component, it's going to have a y component. This b minus a is going to have an x component, is going to have a y component. How do we find the x components of a plus b? How are we going to get the x components of a plus b?
The x component of a plus b will be equal to the sum of the x component of a plus the x component of b.
Okay. So this is equal to this. Ax plus bx. We have ax, we've got bx, so we substitute. Is that clear?
Yes.
Yes.
Plus the y component of this, x component of this is 18. There, so we have this guy. The x component of A is minus 27.2 meters. The x component of B is minus 18.8 meters. So that will be minus 27.2 meters plus 18.8 meters. That will give us how much? How much are you going to get?
Negative 8.4 meters.
8.4 meters. Similarly, on the y bit, we do the same thing. That's going to be where is this? The a plus bx y is going to be ay plus by. Like that. So ay, we know ay is there. Ay is 12.7. Oh my God. Just a minute. AY is 12.7. Then plus BY is minus. So BY plus minus this. There. 12.7 meters plus minus 6.8 meters. How much we get?
5.9.
5.9. Where have I written that? What? Where have I written? I'm not seeing something. How do I create space now? It's like the other stuff has gone on the other side. So the only thing I need to do is probably get rid of this bit. Let's see. Okay, so I don't have a lot of space, so I need to do a bit of deletion. Like that. So I need to do that so that things fit. Otherwise, things don't fit, and you won't see stuff. Okay. Which means same applies to this. I need to delete a bit of something. So this is going to be how much? The b minus a minus b. How do we get a minus b? It's going to be ax minus bx, I think. Yeah, these. So you have to subtract the x components, the components. So it's going to be ax minus bx, and ax we already have it from there. So x minus bx. It's going to be minus, then how much is that? Ax is minus 27.2. Ax minus 27.2 here. Bx is 18.8. So basically what you have for Ax minus Bx, you have what? Minus 27.2 minus 18.8. How much is that?
Negative 46 meters.
Negative 46 meters. Negative 46 meters. Okay, we do the same thing for the y bits. AY minus BY. That's the bit. AY minus BY. So AY is there, that's AY. BY is that. So it's going to be, when you write that, minus how much is that? AY is 12.7 meters minus 6.8.
19.5.
19.5. Okay. Next we go to B minus A. So B minus A is going to be where bx minus ax. Yeah, bx minus ax. Bx is 18.8, ax is minus 27.2. So we write those there. 18.8 18.8 minus like that. So 18.8 meters minus 27.2. How much is that?
46.
46. 40, 46 meters.
46 meters. Okay. Then the other one is the last bit. by minus ay there, by minus ay, by is this minus 1.6 meters, ay is 2.7 meters. So write that minus where's ay is that. Okay, like that. So we have minus 6.8 meters minus 12.7 meters. How much do you get?
19.5.
How much?
19.5.
Negative what?
Negative 19.5.
Negative 19.5.
19.5.
Okay. Okay, so now we have filled up our table. For vector A, we have the x component with the y component. For vector B, we have got the x component and y component. For A plus B, we have got the x component of A plus B. For A plus B, the y component, we have it. For A minus B, the x component, we have it. For A minus B, the y component, we have it. For B minus A, the x component, we have it. For the y component, A minus B, the y component, we have it. Is this clear to everyone?
Yes, sir.
Yes, sir.
Okay, so if you want to find the next way, I think we have got it's now 11:14, which means I've got about 15 minutes. I am going to work out for A plus B. We'll try to work out for A plus B. Okay, so vector A plus B. Now for vector A plus B, the x component of vector A plus B is negative 8.4. That means that the x component of A plus B lies along the negative x-axis. Okay? The y component of A plus B is 5.9. It's positive. That means the y component of A plus B lies along the positive y-axis. So if the x component lies along the negative x-axis, the y component lies along the positive y-axis, then A plus B is in the second quadrant. Is that clear? The x component of A plus B is minus 8.4. That means it lies along the negative x-axis. This x component. The y component is 5.9. It's positive, so it lies along the positive y-axis. Therefore, A plus B lies in the second quadrant. Is this argument clear?
Yes, sir. Yes, sir.
Okay. So at least we have an idea of where that vector lies. So I'll copy something. I'll do the same argument So a plus b. So this on the xy plane, vector a plus b copy. Vector a plus b has an x component which lies along the negative x-axis, and a y component which lies along the positive y-axis. Therefore, vector a plus b. So that's how you find out where the vector actually lies. You have to look at the components. Where do they lie? Therefore, vector a plus b lies in the second quadrant. In the second quadrant of the xy plane. So where is the question? Here. We have to find a plus b. That's what you asked here. Find a plus b. So this is what I'm saying. On the xy plane, vector a plus b has an x component which lies along the negative x-axis and the y component which lies along the positive x-axis. Therefore, a plus b lies in the second quadrant of the xy plane. Next, we proceed to find the size of a plus b, the magnitude. Okay. The magnitude of a plus b, where is next we calculate the magnitude of a plus b. Vector a plus b yep. So we want to find the magnitude of a plus b, and how do we work that out? So again, equation. How do we work out this? How do you get the magnitude of a plus b? How do we work the magnitude? Want the magnitude of a plus b, how do we find it? Hello? How do we find the magnitude of a plus b?
So magnitude of a plus b, we equate the magnitude of a plus b to the root of a plus bx squared plus a plus by squared.
Okay, so there has to be an a plus b somewhere. Where is that? This. Just write that. Squared plus like that. So it's a plus b squared ax plus bx, the whole thing squared, plus ay plus by, the whole thing squared. We know these. We know ax plus by from the table. From our table here. Ax plus bx, that is minus 8.4. Ay plus by, that is 5.9. So we substitute those values. Just a minute. So ax plus bx, that is how much? What am I looking at? That is minus 8. 4. Just a minute. Then the other one is 5.9. Where are we? Here. So ax plus bx is minus 8.4 meters. Ay plus by is that. Can someone do the whole calculation and give us some size? You don't have a lot of time. What do we get after you square root everything? How much?
10.2.
10.2.
10.3 meters.
10.3.
No, 3. 10.3 meters.
Okay. So that's how I get the size. So the size is 10.3 meters. So we have the size of vector A plus B. The next thing left is for us to find the angle. Okay. Now vector A plus B lies closer to the negative x-axis. Okay, so I'll write that. Vector A plus B lies closer to the negative x-axis than to the positive. Remember, you always measure angles from an x-axis. It's either from the positive x-axis, from the negative x-axis. When you're measuring when you're using the angle theta, you're measuring them from the positive x-axis. Yeah, so vector A plus B lies closer to the negative x-axis than to the positive x-axis. The angle vector A plus B, the angle vector A plus B makes with the positive x-axis, is denoted. The angle of the vector A plus B makes the positive x-axis is denoted. That's what you call theta. Let me print out this so you can see what you're doing here. So what you're saying here is vector A plus B lies closer to the negative x-axis than to the positive x-axis. Okay, because we know, the reason why we're saying this is because we know A plus B is in the second quadrant. the angle of vector A plus B mixed with the positive x-axis is theta. So if you measure the angle from the positive x-axis here to where the vector is, that angle is what you're calling theta. The vector A plus B mixed with the negative x-axis the angle of vector A plus B mixed with the negative x-axis negative x-axis is denoted phi. That's what you call phi. The angles, in this case, the angles theta and phi, the angles theta and phi are related as follows. Theta is equals to 180 plus phi. There. That's how theta and phi are related. Theta is equals to 180 degrees plus phi. So in our case, we're going to work out phi, and phi is going to come out to be a negative angle. We work out if your vector is not in the first quadrant. If your vector is not in the first quadrant, it is in the second quadrant, third quadrant, and fourth quadrant, you always have to work out the angle phi. Okay? If your vector is not in the first quadrant, second quadrant, third quadrant, you always have to work out the angle, the angle phi. We calculate, work out phi. As for using what? So how are we going to work out the phi? Tan phi how are we going to work out tan phi for A plus B? Tan phi will be how much? How much will be tan phi? Okay, so tan phi is going to be these guys divided by this lot. Like that. AY plus BY, then AX plus BX. So AY plus BY is that. Then the other bit is this, then X component. Like that. How much is that?
$35.1.
How much?
35.1.
Huh?
Degree.
I'm looking for tan phi. Tan phi. I'm not looking for the angle.
Negative 0.7.
How much?
Negative 0.7.
Negative 0.7. 7. There. Next, we work out what phi is. Phi is going to be equals to tan inverse phi is going to be tan inverse of negative 0.7. How much is that? Negative what? 35. Like that? Is this correct?
Yes.
Okay, so now that we have got our phi as negative 35, we can get theta. We get theta follows from, we get theta as from here. Plus how much we get there? Theta is equals to 108. How much?
145. 145 degrees.
145. Okay, so the angle from the positive x-axis is 145 degrees anti-clockwise. Then the size of a plus b is 10.03. Yeah. 10.03 and 145 degrees. Is this clear? Is what you have done clear?
Yes.
Okay, we have run out of time, so we'll continue tomorrow evening. We work out a minus b and b minus a. So most likely, I think what you're going to be able to accomplish by the end of tomorrow is a minus b and b minus a, since it's just an hour. Then that's why I was saying we need Thursday and we need Friday at some point next week. But yeah, this is enough information for you to start. I will add the rest of the questions to the tutorial thing, so and post it on Moodle. I don't know if you guys have got access to the tutorial sheet. Do you have the tutorial sheet?
Yes, we do.
Okay, so basically, if you have tutorial sheets, that's fine. Which means you can follow the same steps we have been doing, trying to follow these steps and try to work out. So basically, tomorrow we'll meet at 18 hours. Then I'll send you an invitation for Thursday and Friday. Please accept the invitations. We still have only about half the people have accepted the invitations. The other half have not. So in the meantime, whatever we have here, I'll stop the recording. I'll post it on your anyway, I'll post this on your WhatsApp group so that when you are done, or with the WhatsApp group and also on Moodle, because there's also a video recording which is